Hello everyone. Today we are going to discuss section 15.9 on the change of variables in multiple integrals. Now we went from double integrals to polar integrals, double integrals using polar coordinates, from rectangular coordinates to the polar coordinates. Let me put it that way, from polar coordinates, and we went from rectangular coordinates to cylindrical coordinates. We went from rectangular coordinates to spherical coordinates. So we have been changing the coordinate system for the last few sections. Now they are putting it together in this section as change of variables. So broadly speaking, you want to be able to move from xy plane to uv plane. Uv could have been r and theta, or it could have been xyz, could have been xy to r and theta. You want to move back and forth, or you want to go from xyz to r, theta and z, or you want to go from xyz to rho, phi and theta, back and forth. Okay, so broadly speaking, you want to be able to move from uv plane to xy plane, or xy plane to uv plane. So now they are saying if T is a mapping transformation from UV to XY, then T inverse would be a transformation from XY to, if this is T, then obviously going back would be T inverse. Okay, that's what they're trying to say here. Now, how would you go? The transformation would be that. You would, first step one would be, you would find equations for x in u and v, and find equations for y in u and v. Then you want to find, step two would be to find Jacobian. Jacobian is nothing but just this, okay, this determinant of a matrix. You want to find the Jacobian. Step 3 would be, you want to write this as dx dy as absolute value of Jacobian times du dv. Okay, that's one way you want to go. If it is like if for example, if your function has like say x is a function of g is r, theta and z, and y is a function of h, r, theta and z, and z is a function of z itself. Okay, then your Jacobian would be partial u, partial x, partial u, partial y, partial u, partial z. Then you have partial y, this would have been partial x, partial u, partial x, partial v, then you get partial x, partial z. Okay, then if your y is in the function of r, theta and z, okay, this would have been r, theta and z. Y is a function of r, theta and z, then your Jacobian, the second row in Jacobian would be dou y, dou r, dou y, dou theta, dou y, dou z. Okay, now if then you want to go for the third row. The third row would be partial z, partial r, partial z, partial theta, and partial z, partial z. So this goes without saying that if I can write this as xr, x theta, xz, yr, y theta, yz, 0, 0, 1. So then what happens is, I'm off the screen. Then you would have got dx, dy, dz would be absolute value of Jacobian times dr, d theta, dz. I hope that is clear. That's how you make a transformation. Okay, and I did a problem here. Here the problem is x is given by u squared minus v squared, y is given to be 2 times uv, and your uv is such that u is varying between 0 and 1, v is varying between 0 and 1. You want to find the image of the square. So in other words, this S is depicted by a unit square. That means it is the square of a square whose side is unit length. By running through all the computations, what I showed you is that this square would transform into this kind of a picture. It looks like a semicircle, but it is not. It is more like a parabola. My picture is bad. So this is a square. So under the transformation, it became a parabola. Okay, this is not a what is that? This is not a semicircle. Please remember that. So now let's move on and do a separate problem here so that you understand this. Okay, now use the change of variables to evaluate this. Now if you want to evaluate this integral in the rectangular coordinates, you can try it, but it might be a little difficult. Let me adjust this. I don't know how it's going. So if I get that, then I have off the screen right here. Okay, I'm not able to adjust. It's fine. Let's go on. If I want to do this in the rectangular coordinates, I would maybe lose out on, it would be more difficult, okay? So what I want to do is I want to make sure I want to do this using the make a transformation and integrate it using the transformation. So the first thing is I want to replace integral y is given to be 2uv, so I want to write 2uv, but I want to find the Jacobian first, okay? So for me, x is going to be u squared minus v squared, and what is that? Y is going to be 2uv. So then I'm going to find out xu first, that's going to be 2u. Then I'm going to find out xv, that's going to be negative 2v. Then I'm going to find out yu, that's going to be 2v. Then I'm going to find yv, which is going to be 2u. So my Jacobian here is going to be xu, xv, yu, yv. Okay, so my Jacobian here is going to be determinant of 2u, negative 2v, 2v, and a 2u. So which is going to be 4u squared plus 4v squared. So now if I want to transform the thing, it's going to be dA is going to be absolute value of Jacobian times du dv, right? And this is anyway positive, so absolute value of positive is going to be positive, so dA is going to be, I'm going to write this as 4u squared plus 4v squared and a dv here. Okay, so now this is going to be here 4u squared plus 4v squared and du dv, okay, du dv. But now the question is, what would be my limits of integration? That's what is my question here, okay? What would be my, let me zoom in a little bit so that, what would be my limits of integration? That's what is the question. I mean, you know, it's on a suitable domain, right? So if I have this, remember my problem, I said I changed, remember I transformed the unit square into a parabola here. The work is on the picture, the work is on the paper, and I will upload it separately. So basically that this is nothing but a parabola, and you can see from the previous problem this is going to be transformed from the previous problem okay. This is going to be the parabolas are going to be, the parabolas are transformed into a unit square, okay? unit square. So if you're transforming it onto unit square, then what you get is you get 0 is less than or equal to u is less than or equal to 1, 0 is less than or equal to v is less than or equal to 1. So then your integral would be 0 to 1, 0 to 1, then you get what 4 times 2 is 8, u cubed the v plus 8 u v cubed and a du dv. Let's go integrate it with respect to u first. When you integrate it with respect to u, then you get u to the 4 2u to the 4v plus 4u squared v cubed, where your limits of integration is 0 to 1 and a dv, right? Then upon substituting the limits of integration, you get 2v times 1 to the 4 minus 0 to the 4 plus 4v cubed times 1 squared minus 0 squared, and you get a dv. So that's going to be integral 0 to 1, you get 2v plus 4v cubed dv. So now upon integrating, what do you get? You get v squared over 2, and 2 and 2 gets cancelled out, so you get v squared plus v to the 4, where your limits of integration is going to be from 0 to 1. So this would give you 1 squared, upon substituting the limit, you get 1 squared minus 0 squared plus 1 to the 4 minus 0 to the 4. Okay, so that's going to give you 1 plus 1, and 1 plus 1 is a 2. So what we found out was that using the change, using the this is 2 is 2 units. I mean, actually it will be cubic units. I will explain you why. Okay, now if you look at it, I mean, this is a double integral and you have an integrand. Remember, double integral, if your integrand is 1, you get an area. Otherwise this is going to be considered as the width, and you will find out if the integrand is a function, then you will get a volume, and volume is 2 cubic units. Now remember, if you wanted to do this on the rectangular coordinate, it would have been difficult, but with the transformation, this problem turned out to be more simpler or more easy, and you got the answer very easily. Now remember, but also remember that you are lucky, because in this problem they already gave you that the transformations were x equals u squared minus v squared and y equals 2uv. Had they not given these transformations, it would have been more difficult. And will I be able to come up with the equation like that, with the transformation like that? No. So let's just feel happy that they have given us, and we will use it and transform the domain, and then apply suitable limits of integration and find the volume. So in this section, what we did was we explained the rationale behind the transformation from rectangular polar, rectangular to cylindrical, rectangular to spherical, and I explained the meaning of Jacobian to you. And then based on the problem that I would upload it later, I explained how you would find it. How would you find the volume of a certain object. Now let me also show you something. I mean, how do I say, from when you move to rectangular to polar, you have x equals r cosine theta and y equals r sine theta, right? So that means you're moving really rectangular to polar coordinates. So if you find xr, that is going to be cosine theta, that means derivative of x with respect to r. Then if you find x theta, that's going to be negative r sine theta. yr is going to be sine theta, and y theta is going to be r cosine theta, right? So then what happens is you want to find the Jacobian, because you want to transform, you want to move from rectangular to polar. So Jacobian would give you, Jacobian is nothing but the determinant of xr, x theta, yr, y theta. So that's going to be determinant of cosine theta minus r sine theta, sine theta, r cosine theta, alright? So that would be when you multiply it, you get r cosine squared theta plus r sine squared theta. So that means when you factor out r, you get cosine squared theta plus sine squared theta. So that's going to be just r, right? So if you want to, and r's radius can never be negative, it will be always positive. Okay, so dA, in other words, dx dy is going to be r dr d theta. So that r is nothing but the Jacobian. We have been using it, but we never got a chance, and I kept referring that I will be showing you in future classes as well. So when you want to move from rectangular coordinates to spherical coordinates, I mean, you said x is going to be, I hope I'm right, sine phi cosine theta, y is going to be rho sine phi sine theta, z is going to be rho cosine phi. So when you find the Jacobian, I mean, you find xr, you find x rho. X rho is going to be what? Sine phi sine cosine theta. And you find x phi, that's going to be rho cosine phi cosine theta. Then you get x theta is going to be negative rho sine phi sine theta, right? Then you want to find y rho is gonna be sine phi sine theta. Then you get y phi is gonna be rho cosine phi sine theta. Then you get y theta is gonna be whatever rho sine phi sine theta, right? Then 0 is gonna be cosine phi. Z phi is gonna be negative rho sine phi, and z theta is gonna be 0. So when you try to find Jacobian, that's gonna be when you find the Jacobian, which is gonna be x rho, x phi, x theta, y rho, y phi, y theta, 0, z phi, and z theta. What you would get is you would get rho squared sine phi. Okay, that's what you would get. I mean, plug in and find the determinant of a 3 by 3 matrix. You must have learned how to find the determinant of 3 by 3 matrix in pre-calc, then you would get the same thing. I hope this is clear. With this, I will stop section 15.9. I will see you again with a new recording on section 16.1. Till then, take care, stay safe, bye bye.